All right, so today we deal with answering questions. Remember, part one, we dealt with electrodynamics, the whole story of electrodynamics. Today we're just going to bring information from what we've learned so far. And in our second session, what did we look at? Photoelectric effect again. And I want to tell you that that was a very detailed class. The photoelectric effect one, it was detailed. With the animations, I'm sure it gave you a better picture of what's going on. So today, let's just quickly answer a few questions. I'm going to start from here. All right. So the diagram below shows a simplified photocell. And you would see that light is shining on a metal there. Light is shining on, that's called a vacuum. It's in a vacuum, okay, just to avoid air disruption. And you have an ammeter here, which is going to measure what? Current. So understand the topic again. The graph below shows the relationship between the maximum kinetic energy of the photoelectrons. I said, don't be dazzled by the word photoelectrons. It's just electrons. These are electrons released by photons. That's where the word comes from. Okay. And the frequency of the light, when the light is shown upon the metal surface of the above photocell, the graph cuts the X. We saw what graphs did yesterday, right? By saying, if you have frequency, what is that X intercept? Threshold frequency. Don't forget those little points. They'll assist us. 5 times 10 to the power 14 hertz. Let's look at the graph. All right. We were told that what? F1 is 5 times 10 to the power 14. Let me just put a note here so that we don't forget. F1 is 5 times 10. Oh, okay. The graph is actually on top there. 5 times 10 to the power what? 14. Already we all know that is what? Threshold. Guys, as I kept mentioning this thing, let the definition run through your mind. What is threshold frequency? The minimum frequency of light required to eject or emit or remove. Whichever word you think first. Okay? Eject, remove. Don't write chase away. Okay. All right. The minimum frequency of light needed to eject, remove an electron from the surface of a metal. Okay. All right. So, 10.1. I think we're done with 10.1. What is it? Work function. Threshold what? Frequency. I'm already answering number 2 in my head. Now, what is work function? The minimum energy required to do what? To reject, remove an electron from the surface of a metal. So, look, those are the standard definitions that you would get. There are 5 of them. What are the 5? Let me help you. Be able to define photoelectric effect, work function, threshold frequency, photon. What is the 5th one? The 5th one will be to talk about the nature of light. Okay? And we say light acts as what? A particle. Don't forget those information. Calculate the work function. Please, guys, learn to write what you know. I want to show you how to get marks when it comes to physics. What are we looking for? Work function. Go to your formula page. Check the formula for. I'll give you a secret, guys. This little secret here. When you see 3 marks in a work function, it's just one formula. In most cases, 3 marks is one formula. When you see 5 marks under photoelectric effect, you are going to use E equals to plus. That's one little secret. Can you please check your formula pages? Examiner says calculate the work function. What's the formula? Work function equals to what? H F naught. You remember that, right? What is H? Planck's constant. And what's the value? I need your calculators here. 6,63 times 10 to the power negative what? 34. Right? And what is our threshold frequency? We know it as what? 5 times 10 to the power 14. What is your answer? 3,32 times 10 to the power negative 9. And what's the unit? Joules. My dear learners, check your first 3 marks. It's your first 3 marks in the bag. Oh, not just the first 3 marks. We are sitting on what now? 6. Because we understand the graph. We understand the definition. We do one little simple calculation. This is grade 8 calculation. We get it. Is that okay? Now, look at the second one. Calculate the frequency F2. Examiner. Examiner is now testing you there. Do you know your graphs? All right. Guys, check. Now, examiner says calculate the frequency of what? F2 as shown on the graph. Now, what do you notice on the graph? We've got F2 there. But what do you have here? 11. Just bring in your maths. Or if you like, let me do it in 2 ways for you. Is that okay? Let me do it in 2 ways. We have the work function of the metal. What are we looking for? Frequency there, right? Oh, easy. What is this? Kinetic energy. So let's check. What are the things we have? We have EK. What is EK? 11 times 10 to the power what? Negative 19 joules. Make sense, everybody? We have our work function. What's our work function? 3, what? 32 times 10 to the power negative what? 19. What are we looking for? We are looking for F. Please take note, not threshold anymore. The fact that I have all of this, you know what the formula I'm going to use? Okay, we can say E equals to work function plus what? EK. But are we really looking for E? No. But we know F is hiding there. So, HF equals to work function. You see here, it's calculator usage that I'm worried of. Okay? F would be equal to, what is our work function? 3, I want to do something. I don't know if it's going to be okay with you. Tell me if you are okay. Plus, what's the kinetic energy? 11 times 10 to the power. I don't know if you are okay with what I did here. From the second step. What do? We divide both sides by what? By H. What is our answer? Let's calculate. Because I want us to do something else. 2, 16 15 unit hertz. But I want us to check something very nice here. From what we did yesterday, what did I tell you about the gradient? You check your x-axis, right? If you remember. What's on the x? Frequency. I told you when you see that, bring in the formula that has F. Oh, so what is my H? The gradient. Make sense? Let's try to play around with that. Can we then say y2 minus y1 over x2 minus x1? Okay, wait, hold on. Let's see the graph. We have something like this. We have something that looks like this. And we know this as 5 times 10 to the power what? 19, right? We're looking for F2 there. Let's play around with a bit of physics. What do we know here? 11. What is this? 0. What is our gradient? H. Remember that, right? Y. We have what? F here. How do we calculate gradient? Change in Y over what? Change in X. But what is our gradient? Do you remember it's H? Now, what is our change in Y? I would say change in kinetic energy over change in what? Frequency. Make sense? Using the exact labels that I have. Oh, what is this? 11 times 10 to the power, is it negative 19? Are you sure? Okay, I don't trust you. Negative 19. You say, I made a mistake here. That's why I don't trust you. This one is 14. I wrote 19 and you all agreed. No, I trust myself. Yeah, I wanted to test you if you are following, but I see that you're not following. All right. Minus 0. Does that make sense? Over what? F2 minus 5 times 10 to the power negative what? No, not negative. It's just 14. But what is H? 6,63 times 10 to the power negative what? 34. Do you notice the only thing missing is F2? Quick maths. You can cross multiply. Anything minus 0 is that thing, right? Okay, you know what I'll do? I can put this, I want you to learn this. If you have A equals to B over C, you can simply say C equals to B over A. I want you to learn that quickly. Because what would you have done? You will have cross multiply, then divide by what? A. You're going to get a lot of that in physics. So just understand what to do. I'm just going to switch places. Check. F minus 5 times 10 to the power 14 equals to what? 11 times 10 to the power negative what? 19 over 6,63. Let's check our answer if it's going to be the same. Do the division. Please, when you do this, I need a calculator. Let me bring one. Please, when you do this in this topic, learn to use this button. If you start using this button, you are looking for trouble. So we use this one. So what do we have? 11 times 10 to the power negative 19 minus 0 if you want to waste your time. Divided by what? 6,63 times 10 to the power negative what? 34. That will give us that. But we need to take that one to the other side, right? And it becomes what? Positive. Plus, I'll do that. 5 times 10 to the power of what? 14. Let's check our answer. 2,15. What did you? 2,1. Are you sure? Okay. So this is 159. And if you round up to 2 decimal places, what do we have? 2,16 times 10 to the power of what? 15. So it means our principle that we used on the graph is correct. Do you remember that principle? The principle of y equals to mx plus c. You see it works. Because that's what I used here now. Understanding that my gradient is h. By rearranging y equals to mx plus c. How many topics? Throughout the paper. No need to list. I can show you Doppler effect. When we get to Doppler, please remind me when I get to Doppler effect. Just tell me graphs. Oh, free state. So graphs just keep appearing everywhere. So you cannot run away from the concept of graphs. It is very important. Okay, are we okay so far? So please, don't rush. Take your time. You would finish. Even if I don't finish, I'd rather do the things I'm doing perfectly than do the whole paper with lots of mistakes. The intensity. Oh, we spoke about this yesterday. Let's quickly explain what intensity is again. Intensity talks about what? The brightness of light. And intensity refers to the number of what? Photons. Quickly. Number of photons will affect number of electrons. But kinetic energy will remain what? The same. Lovely. So, the intensity of light is increased while the frequency of the light is kept constant. How will this affect the reading on the ammeter? Let's go through the process. The number of photons will, if it increases, it means the number of electrons will increase. What happens to current? Current will increase. Let me give you a detailed answer because some are joining us today. Increase in intensity. So if the examiner says explain, this is what you write. Will increase the number of photons Therefore, increasing the number of electrons emitted. All right? And current increases as more electrons flow per unit. If you answer like this, examiner can even be forced to give you extra marks. They'll defend it later. Because you have nailed the examiner. Do you know that we have defined current also? You have defined current. You have nailed them that current is inversely proportional to time. You have nailed everything like this. Increase in number of photons, increase number of electrons emitted, and current what? Increases as more electrons flow per unit time. Do you know the formula I'm using? I equals to what? If you remember, I wanted to take it step by step, but do you remember how we got that formula? Where N is what? The number of electrons. So if you have more electrons emitted, current will increase. We're done with that question. Check. Done. We okay? Everything I'm just taking from the class and just, it's like you are doing column A and column B. Match the information, match to the question. Let's go on. Let's check this. Photoelectric effect confirms the particle nature of what? Light. Describe the term photoelectric effect in words. How would you define that? No, you missed. Okay. Photoelectric effect is the process where electrons are ejected from the surface of a metal when light of suitable. Now, Tess, you see the statement, suitable frequency. Because not all light emit what? Electrons. Of suitable, light of suitable what? Frequency shines on it. Okay, I just have a little clause on that. Because if you generalize by saying, what did you say again? Okay, but not all electromagnetic radiation will eject based on the metal you use. Of suitable frequency. For me, that line is key. Otherwise, we are saying all lights emit what? Electrons. Okay. All right? The work function of a metal is 5. Please, I want you to enjoy physics. Write the information down. What do we have? Work function of a metal is 5,6 times 10 to the power what? 19. So what do I have? Work function is 5,6 times 10 to the power, is it negative 19? Joules. Let's see. I want you to enjoy it. Light of wavelength 450 nanometers. Na. In case you forget, pronounce it na. There's a number. 9. So 450 nm is what? 450 times 10 to the power what? Negative 9 what? Meters. You must convert. I want us to see. Define the term. Well, I'm not doing that again. We did that earlier on. Is that okay? Besides work function, write down 2 other factors which affect the photoelectric effect. Besides work function. Kinetic energy, will it affect photoelectric effect though? Besides work function, write down 2 other factors which affect photoelectric. Good. We can talk about the intensity of the light. Why? When intensity is high, we expect more electrons to be released. Number two, energy of the light. Right? Why? If you have energy lesser, if you're using energy lesser than the work function, you know what we said? Window shopping. That is something. We're window shopping. Okay. All right. Salsa, okay, I'm going to do that graph thing again. Determine by means of a calculation whether electrons will be emitted. If you don't know what to do here, calculate kinetic energy. How would you know photoelectric effect is not emitted? When kinetic energy is negative. We spoke about that. Is that okay? If kinetic energy, it's like you're going to the shops, you want to go and buy chocolate and they collect your money and still not give you chocolate. That's what we said yesterday. So you are going, your money is not enough, you have 10 rand, chocolate is 15 rand. Instead of you come back with 10 rand, they still collect the 10 rand from you. You are a loser, you don't have chocolate, you are a loser, you don't have man. Okay, so if you calculate, but your calculation must be well done. And I remember that I gave you 3 conditions for photoelectric effect. E must be greater than work function. F must be greater than what? Threshold frequency. And the wavelength of light must be less than the threshold. Just for those who are joining us, for the conditions for photoelectric effect. 1, E must be greater than work function. 2, F must be greater than threshold. Number 3, wavelength must be less than 1 over wavelength. And all of this will prove to you that EK should be greater than 0. I gave you this exact note yesterday. Once you get EK as negative, what happens? It means photoelectric effect is not what? Taking place. Okay, let's check. I think we have all our information. Oh, I created another page. Let me do this. Don't want to have too many pages. Okay, let's cut this. And bring it here. Okay, these are my conditions, right? Check everything we know. This is all we know. Can we then prove whether photoelectric effect will take place? Guys, can I ask everyone to calculate kinetic energy for me? Let's check. I'll give you 4 minutes. You must finish in less than 4 minutes. You all have formula pages? Calculate kinetic energy for me, quickly. If kinetic energy is greater than 0, then yes, we have photoelectric effect. Please use a formula page. Everything is there. You're busy with yours. I'm busy with mine. I'm doing something different, so you do yours. 6,63 times 10 to the power that. 3 times 10 to the power 8. 450 times 10 to the power of negative 9. I'm doing something completely different. Just do yours. Tess, stop looking at my screen. You and BB. You are copying my work. What is? Oh, you see it just now. 4,42. what is kinetic energy. Just want to make sure we're able to do those calculations well. Are we done, guys? What is your kinetic energy? Okay. You have negative 1 comma. Guys, in that time frame, you should all be done. Guys, if you calculate kinetic energy, you are getting a negative answer. It's negative 1,18, right? Times 10 to the power. But you don't need to do all of that. These are the conditions for photoelectric effect. Check what I did. I just calculated E. But I know why I'm telling you to calculate E. These decimals can be deceiving. You see, times 10 to the power negative 19. You are going to get some that is times 10 to the power negative 18. And you won't be sure which one is bigger. So if I compare, check, I've got E. What is my work function? 5,6. Which one is bigger? They are both times 10 to the power negative 19, right? So which one is bigger? The work function. But what is the condition for photoelectric effect? E must be greater than the work function. So for me, I'll just say the work function is greater than E. Therefore, there is no photoelectric what? Effect. However, guys, there is nothing wrong. You calculate. How do you calculate? Let's calculate kinetic energy because I need us to see that calculation. How do you calculate kinetic energy? Guys, these calculations are not difficult at all. They are very straightforward. E equals to work function plus kinetic energy. Check your formula. What do you have concerning E? There are two formulas for E. HF, HC over lambda. Check what you have. That's why it's important to write. I've got lambda, so I cannot be writing HF. I go straight for what? Equals to work function plus what? Can we substitute? 6,6 speed of light. It's a constant. 3 times 10 to the power 8. What is our wavelength? Equals to, what's our work function? 5,6 times 10 to the power negative 19 plus what? EK. What happens? You're going to move there. And once you move that there, what would that be? A negative. Throw everything in your calculator at once. Some of you pity your calculator. Oh, my poor calculator, will it be able to do all of this? That's why you bought it. 3 times 10, let it suffer. Use it. Over what? 450 times 10 to the power what? Negative 19. Are we okay there? Negative? Oh, negative 9. Yeah, thank you. Because it's times 10 to the... Okay, yeah. Thank you, Vicky. I will have gotten it wrong. Minus... I'm bringing that whole thing over, right? So what do I have? 5,6 times 10 to the power, negative 19. Check your answer. Negative 1,18. So EK is what? Negative 1,18 times 10 to the power, negative 19 what? Joules. Remember, so I'll say there is no photo what? Electric effect. Why? My EK is less than 0. If you are not sure of the numbers, decimals can be deceiving sometimes. You don't know which one is bigger. Just come this route. Once you get a negative kinetic energy, understand that what? There is no photoelectric effect. And we're done. This is 4 marks, 5 marks in the bag. Everybody okay? So please, the calculations are not difficult at all. Always write what you have down. Go to your formula page and deal with it. We're done with that. Let's check again. Got to move. 3 electron energy levels. We're talking about spectrums here now. Either absorption or emission. We don't know. The wavelength of the spectral line produced by electron transmissions between these 3 energy levels during transmissions are 486 nanometers, 656, and 1800. Copy the diagram above and draw arrows to show the electron transitions between the energy levels that would give rise to this wavelength. Label each arrow. Okay. An examiner is talking about, let's see. They said emission. What I was looking for. Emission. Are my arrows going up or coming down? Coming down. Right? Okay. And I see that there are, let's see how many arrows we can draw here. We can draw this one. Let me see. Make it thinner. We can draw this. We can draw this. And we can draw this. Right? Do you see the 3 of them? What did we say? Energy is what? Inversely proportional to wavelength. The one with the smallest energy has the longest wavelength. Which wavelength? Which one has? Let's label this. Let's call this A. Let's call this B. Let's call this C. Which one has the longest? Which one has the smallest energy? A. What does that tell you? It must have the longest wavelength. What's my longest wavelength? 1880. So this one is what? 1880 nanometers. I hope it's making sense. Don't get confused. Already you are tears. I see your face. E and wavelength are what? Inversely what? Proportional. The one with the smallest energy. Remember the formula. E equals to what? HC over the one with the longest here would have what? Smallest energy. And that's the energy difference there. That's space. So 1,880 nanometers is very long. Although in your eyes you are thinking now it's short. The fact that it produces a small energy means it has a very long what? Wavelength. Not the length of the arrows. You guys are looking at the length of the arrows. Guys, here is your key. That's what the examiner wants you to do. But we know that the one with the smallest energy has the what? Longest wavelength. A has the smallest energy. Hence has the longest what? Wavelength. Okay, can we fix B and C? C has the biggest what? Energy. Therefore, it has the shortest wavelength. Which one is the shortest? 486 times nanometers, right? And obviously, B is in the middle, which is what? 656 nanometers. Label each arrow with a wavelength. Are we okay? Again, we're using our knowledge of the formula. Energy. Remember we spoke about the sun yesterday. Okay. And frequency is inversely proportional to what? Wavelength. All right. We're done with that. Oh, let's see. I need to move to other topics. Okay, these are just formula pages and whatnot that we used. We answered this multiple choice yesterday. Remember again? Let's see. Oh, we answered this one yesterday. We don't need to start. We did this. Okay, but let's go through the full question of this one. Okay? Salsa, I'll be helping you again here with the gradient. So, you can just follow through again. Let me clean everything we wrote here and do it afresh. And from here, I'm moving on to electric circuits. This is the last question on this one, hopefully. But if you find any other question that you can, please, you can look for November 2017. There you needed to plot a graph. You needed to sketch and plot the points, sketch a graph. I think it's November 2019 or so. I'll see. Probably I'll bring it up in the next session. We sketch the graph together and calculate. All right, different frequencies. Please read this very well. Different what? Frequencies. I'll tell you why. Examiners are going to ask you for independent variable. Different what? Whatever you are changing is your independent variable. So we see that different. You see it on the X. All right. As shown onto a surface of a metal cathode or photoelectric cell, the graph below shows the relationship between the maximum kinetic energy of the photoelectrons and the frequency. Already we know what our X is. If you were with me for yesterday's lesson, what's X? Beautiful. Work function. What is F? Not here. Threshold what? Frequency. We know that. This is F, right? And we know that since you see that formula, what's coming to your mind? HF. So what do we know? Gradient equals to what? H. Quick analysis. Then we get our marks. I'm tired of defining work function, honestly. Give a reason why. Okay, check this. Give a reason why no photoelectrons are released when light of. Good, I love this. It will allow me to explain. This is threshold, right? Any frequency here below 50, there will be no what? There will be no electrons. No what? Electrons removed. Do you know why? Do you want to tell me why? Somebody's changing my screen there. Please. Don't change any settings. Just enjoy the class. All right. Guys, are you okay with me saying there's no electrons removed there? Why? Those frequencies are lesser than what? The threshold. Threshold means the minimum. So if you have anything lesser than the minimum, there's nothing that will happen. I have already answered that question if you see. Give a reason why no photoelectric effects are released when light of that. Why? It is lesser than what? Than the threshold what? Frequency. We're done with that question. We move on. Guys, I don't know if you see this topic as something light to pass through easily. Just know your concepts. What quantity can be determined? Did we answer that already? Yes. What is this? Planck's what? Constant. All right. Is it fine if you don't spell it right? There's a formula page. And it is written there. And you have something on the formula page. It says copyright reserved. We have reserved the right for you to copy it. Tess, don't come with that thing of spelling of, because it's there. Oh, this child. So, why would you copy it wrong? Where is it? Uh-huh. P-L-A, P for pillow, L for London, A for apple, N for nano. Okay. I know you're making jokes here. So we need to spell it right. Okay. All right. Let's just run. Calculate the magnitude of x. What are we looking for? Work function. There are so many ways of getting this work function. The first thing. So if a learner doesn't know that that is x, that is work function, learner might have a problem. Do we know threshold frequency? We know 50. Oh, let me show you two ways of getting that quickly. First thing, I know I'm looking for work function, right? Work function equals to what? H F naught. 6,63 times 10 to the power negative what? 34. What is our threshold? 50, right? Times 10 to the power what? I'm not sure. What is it? Just 50. No, something is missing. It's times 10 to the power 14, right? Okay, you want to get me an answer? Quickly, everybody. 5 times 3, 5, 30, 31. That is 3, 31. 3, 3,315. Negative 18. This is wrong. 19. Okay, all right. Please, everybody, let's check on our calculator now. It's not me, but this answer is still wrong. Joules. Yes. It's wrong. Okay. So that is how you work it out. However, we said something about what? That we could use. Okay. All right, so we have that. And remember what we said yesterday. What is this? Work what? Function. We said M is equal to what? Gradient. Remember what we have there? 0. What do we have here? 50. I think we can walk through from here. We can. Because I can talk about 0.2 and 0.1. We're looking for gradient. So, gradient would be equal to what? Change in kinetic energy or change in Y. Repeating what I did earlier on. Change in Y over what? Change in X. This is EK and this is what? Frequency. But what do I know as my gradient? H. And this is change in what? Kinetic energy over change in frequency. You shouldn't let examiners trouble you with all of these kind of formulas. Just use your graph. Do I know my H? 6, what? 63 times 10 to the power negative 34. What is our change in kinetic energy? 0 minus work function. Does that make sense to you? 0 minus work function over. What is our frequency? 50 minus 0. But don't forget, it is 50 times 10 to the power what? 14. Are we together? Make sense? All right. Can we cross multiply? What are we going to get? 6,60. You don't need. Are you pressing that again, baby? You don't need to. Check on top there. What do you see? Do you see we have the same values? 6,63 times 10 to the power 14, 34 times. It's exactly the same. Why is it negative? It is below the x-axis. That's why it's your negative there. So we know that our work function therefore will be what? 3,315 times 10 to the power negative 18 joules. So please understand your maths. We're still using y equals to mx plus c. We're done. Make sense? All right. Easy stuff, guys. Just enjoy the question. Light of frequency 110 times 10 to the power 14 hertz is shown on the metal. I want you to do this for me. Calculate the speed. What are we looking for? What symbol? V. C is the speed of light. We said that yesterday. V now is the speed of the electron. Yes. Yes. This is not Doppler. V is just speed. All right, let's calculate the speed. This is a common question as well. Listen, before you start, let's make a list of what we have. What do we have? They said light of frequency, so we know what? F. That's the first thing. So everybody, let's write down F. 110. That's how to make calculations very easy for you. What is F? F is 110 times 10 to the power what? 14 hertz. Mind you, what are we looking for? We're looking for what? V. What else do we know? We know our threshold frequency, right? Yeah. What is the threshold? 50 times 10 to the power what? 14. You know the only place, let me quickly guide you. The only place you are going to get V from is from kinetic energy. Because kinetic energy is half mv. So what formula would you use? E, because you must get EK first. Equals to what? Work function plus what? Kinetic energy. Now let's check. I'm already doing this whole thing to save time. Which of the formulas will I use for E? Go back to the list that you have. No, I need E. Which formula would you use to get E? There are two of them. There's HF, there's HC over wavelength. What would you use? Huh? Biggie, check the board. What do you have? Do you have wavelength? No. So there's no need to go to HC. Use. All right. What about work function? Check again. You have F naught. There's no need to go to C. Just bring that in. HF naught. Plus. What is your EK? Half MV. Wait, you can put all of that at once if you trust your maths. You do have M. I did mention it. It's an electron. Check on your constant page. I did mention when I was talking yesterday that if you weigh 9,11 times 10 to the power negative 30, something's wrong. So, guys, can we do our substitution? I need everyone to calculate with me. What's our F? What's our H? Please don't write this from your head. I'll tell you why. You could have made a mistake of writing 34 instead of negative 34. Right? Don't say, now I'm the boss. This light will shock you. Please. What is my F? 110 times 10 to the power what? 14. Are we there? What is my H again? 6,63 times 10 to the power negative what? 34. What is our threshold? 50 times 10 to the power what? 14. Plus. I want us to do the math together. Half. Now, some of us don't know the math. Let's go to our formula page so that you know where to find it. We are talking about electrons here. Check your formula page. Second to the last one on the constant. Electron mass. You see there? 9,11 times 10 to the power what? Negative 31. That's where we get the mass from. So what do we have? 9,11 times 10 to the power negative 31. What do we have? V squared. Please, I want you to see what I'm going to do. I know you guys like a lot of calculators and pressing, but it's fine. To make our life easy, look at what I'm going to do. I want you to follow. I want to press my calculator once. Yeah. I'll type all of this once. Is that okay? This is a whole entity. What am I going to do? Bring it over. It's going to become what? Negative. Let's start from there. Guys, there's no mark in doing all of these things step by step. So what do we have? Use a bracket. But if you are not comfortable with what I'm doing, please use your way insurance. This is my way. Times 10 to the power what? 14. I'm done with my left-hand side. Make sense? Please use brackets. What am I doing on the right-hand side? Bring that entity over. What does it become? Negative. Put a bracket again. What do you have? 6,63 times 10 to the power negative what? 34 times 50 times 10 to the power what? 14. You see what I have? Let's wait. This is now grade 12. Let's do some maths. Do you see what's happening there? What's happening there? That whole thing is multiplying v squared. So what would you do? We divide now. Divided by 1 over 2 times, or you could do that, 9 comma what? 1 times 10 to the power negative what? 31. That's my v squared. Then what will I do? Square root. But if you're not comfortable with this, you don't have to follow my way. Because Tess, I see your face already crying that, oh, what's this guy doing? 2,62 or 2,69. Is that what you have? What do you have? Why 4? Okay. Now what's happening? What are we doing? What are we doing wrong? Okay. Okay, we are getting different answers here. Njabulo, sorry, I'm just seeing your message now. Which one are you talking about? Okay. Let's see. Wait, do we have all our exponents? Our exponents are correct. Positive is positive and negative is negative, right? Are we okay? Huh? Okay. Everybody, let's do it something. Ladies, give me the one on the left. 6,63 times 10 to the power. Gentlemen, give me the one for the 50. Let's go your way. Okay, let's confirm. Is it? Negative 18. Gentlemen? Come, gentlemen. Let's save time. I can tell that this one will give you. Yes, talk to me. 3, comma. Oh, we have our work function earlier on. Why did I forget? Times 10 to the power what? Negative 18. Plus. Then half of 9,11. What is 9,11 divided by 2? Okay, 3 5s. Times 10 to the power, negative what? 31 v squared. What happens? This one goes there. And then we divide. Can we through? No, Njabulo, our work function is not negative. Okay. You were not in class yesterday. That's why you're thinking it's negative. It's not negative. It's only below the x-axis. That's why it's negative. Work function is not negative. Energy cannot be negative. Okay, guys, I'm waiting for an answer. Don't worry, wasting time. Okay. 7, comma. So give me that answer again. 7,293, right? Is it 7,293? Come on. No, I'm doing the whole thing. 7,293 times 10 to the power. I don't want to waste time. Guys, we are wasting too much time here. Minus 3, what? 315 times 10 to the power what? Negative 18. That will give me that. Answer divided by 4,555 times 10 to the power negative what? 31. We get that. And then we look for the square root of the answer. All right? But the one I did earlier on was in standard form. Shift mode 7.3. 2,96 times 10 to the power 6. 2,96 times 10 to the power what? 6. And what's the unit? Meters per second. Guys, are we okay with the calculation? Please quickly confirm, those of you at home. I am moving on from here. Please confirm, are we okay so far? And those of you that are just getting onto the class, you are beginning to see how to get this question. The questions, we're just repeating concepts right now. Please talk to me. I think I have one more, then we can move to electric circuits. Wait, are we done with that question though? Did we finish that whole question? All right, so you got your 4 marks there. Guys, I told you yesterday that the last question will always be what? Intensity questions, in most cases. Check this again. What effect will an increase in intensity, what does increase in intensity mean? We increase the number of what? Photons. Have on the maximum speed. Remains the same. Why? Number will only affect what? Number. Make sense? The number of photons will only affect the number of what? Electrons. Check. We are done. What's your answer? Stays the same. Explain. Number of photons will only affect what? Number of electrons. Kinetic energy remains what? The same. Therefore, the speed remains the same. You jump from there, you close the paper, you submit, you are done. Oh, other questions? Okay, let's see this one. Let's answer this one. I think this is the last one on, let me see. Even if there's another one, I'm not going to deal with it. Okay, yeah, good. Last one. So let's move here quickly. Let's move on this. The work function of 2 metals are listed in the table below. We have sodium and platinum. I'm done. 10.1. Done. Because almost every question we see now, that's what we're defining. Okay? I'm not saying it's the only thing you are going to define. I told you there are 4 or 5 definitions that you must know there. The sodium surface is illuminated with light, having a wavelength of that. Calculate the energy of the photon. Easy. There's a question I'm going to do tomorrow on photoelectric. We are going to look for it, where they ask you to calculate the number of photons that was ejected. I'm going to look for that question. It's in my head right now, but I don't remember which paper. We are looking for E, energy of photon. Guys, please check what we have. Let's make a list of what we have. Look, don't do too many things yet. They gave us work function, right? And they gave us what? The wavelength. Okay, what is my wavelength? Wavelength is 400 times 10 to the power negative 19. Check. First question is calculate what? Energy of the photon. How many marks? 3. It's one formula, one substitution, one answer with a unit. What formula would you use? HC over that. This thing is so easy. Get your marks. E equals to what? H. And you know why we are using this one? Why? They gave us what? Wavelength. Okay. What is our answer? 6,63 times 10 to the power negative what? 34 times 3 times 10 to the power 8. What's our wavelength? 400. Anybody giving me an answer here quickly? Let's get those 3 marks. Quickly, quickly, quickly. And then you are going to do 10.3.4. I keep writing negative. What? Tabang, what are you talking about? That is negative 9. Which one is negative? Oh, yeah, 400. 400, thank you. Did you use 19 or I made a mistake here? You used negative 9. What's your answer? Wrong. Thank you. Everybody, quickly. 3 minutes. Get me 10.3. The maximum, we just did that example now. The maximum what? Speed. We are looking for V. Everybody, quickly. 3 minutes. Maximum 3 minutes, 30 seconds. Because I'm kind. Let's make it 3:45. 3:40. I remove my kindness of 5 seconds. Quickly. We're looking for maximum speed. V. Once you're done, type your answer in. You're going to? What? Biggie, please leave me alone. Biggie, the information is on the board. Come on. Everything is on the board. Guys, do you have an answer now? Biggie, everything is on the board. Come on, switch on. Let's compare answers now. Mufti, what do you have? 742. Okay, Kwanele, what do you have? Okay, let's see. All right, I'll show you. Okay, let's see. I've got an answer on the screen as well. That's who gave me this answer. Andy gave me 7.42 times 10 to the power of 5. So, Bonga, I'm not sure with your negative exponent, though. I don't know. Guys, We're looking for speed. Biggie, what do you have? We are looking for the maximum speed. People, V. Know where your V lies. Where is your V? It's in kinetic what? Energy. So, do we know the formula? E equals to what? Work function plus kinetic what? Energy. By the way, this is actually easier. Do you know already we have our E? We don't need to recalculate it. What's our E? 4,97 times 10 to the power what? Negative 19. Do we have the work function? Oh, we are using sodium, remember. Some of you forgot which one we are using. You forgot to read. It says the sodium surface. So what's our work function? 2,46. Okay, let's bring all of those. This is a lot easier. 4,97 and 2,46. 4,97 times 10 to the power negative what? 19. 2,46 times 10 to the power negative what? 19 plus half. What is the mass? 9,11 times 10 to the power negative 31. And, come on, people, V squared. I'm just going to go straight to the answer. I'm not even going to talk. What do? We subtract, right? What do we have? 4,97 times 10 to the power what? Negative 19 minus 2,46 times 10 to the power negative what? 19. Is that fine? Divided by what? Or you can use your other button. Answer divided by, you can type all of that in if you don't want to do it afresh. It is 1 over 2. You can do that as well because you are dividing by that whole entity. Let's be smart. I want you to reduce the number of things you write. Negative what? 31. You get that. And then you look for what? The square root of your answer. Done. And if you want to change it into standard form, shift, mode, 7, 3. 7,42 times 10 to the power 5. And what's your unit? Meters per second. Guys, you get your 4 marks there. Please, let me show you how this is marked. Formula, 1 mark. The left-hand side, 1 mark. The whole of the right-hand side, 1 mark. Final answer, 1 mark. That's how it's marked. So please, I don't want us to make mistakes. It's the same thing. Just a second. Bonga, move this one here. What do you have? E minus work function. Done. It's manipulation. Do that. All right. Okay, we are done with that. The same light is now, let's answer the last one, I need to move. The same light is now incident on a platinum metal. Will photoelectrons be ejected? I told you how to do this. When your kinetic energy is negative, it means that photoelectric effect will not be ejected. Or, just simply compare what? What are the conditions? E must be greater than work function. What's our E? 4, what? 97 times 10 to the power negative 19. What is our platinum work function? 6,35. Which one is bigger? The work function is bigger, right? Okay, so that means this condition is not satisfied. What's our answer? No. What's the reason? The work function is greater than E. 2 marks. Please learn the conditions. The condition is that E must be greater than the work function. If it's the other way around, there's no photoelectric effect. I'm done, guys. Look, you can answer any question that they give you here. Should you be practicing and you see any question, just throw it to me and let's look at it together. I'm running right now to deal with ESCOM. Oh, multiple choice. The part label G. Really? But it's so easy now because we went through it, right? If we didn't go through it, we're going to say, yo, G. G is what? G is gravity, and there's no gravity there. Let's deal with ESCOM quickly. Circuits. All right? Circuits. Quickly. Circuits. Now, let's go through circuits quickly, everybody. Let's go through circuits. What the difference between grade 11 and grade 12 circuit is internal what? Resistance. Okay. Internal resistance. And please, what formula are we going to use here? Let me just, in 5 minutes, summarize a few things for you. And I'll do what I did again yesterday. Please, quickly, let's look at this. What are the things I should learn to define? I'm not going to define today. You will have definition pages. Definitions. Number 1, go and define what? EMF. Number 2, go and define lost volts. Number 3, learn to define internal resistance. Number 4, learn to define current. Number 5, learn to define voltage. It's a lot. Voltage. And most importantly, number 6, Ohm's law. All right, EMF is the maximum energy. We must know that. Per unit charge supplied by the, I'm already defining. Oh yeah, we must be, enough definition. These are just the main definitions. Then power, you know the formula. Okay. Number 7, power. Rate at which what? Work is done. So please know your EMF. And know when we measure EMF. When do we measure EMF? When there's no current flowing. So here, we are saying I is equal to what? 0. This is the maximum energy or maximum work done per unit charge by a battery. If you don't put a battery there, it's 0. What is your lost volt? To internal resistance. What is internal resistance? Current. Wow, I don't know what you guys did. Why am I defining? Because opposite to the flow of current. Within, that is important, the battery. Because we are saying it is what? Internal. If you don't put within the battery there, 0. What is current? Flow of charges. What is voltage? It is work done per unit. Guys, if you've been following, I've taught you how to use the formula page to define. Because I know that V equals to what? Q over, no. V equals to what? W over Q. Work done per unit charge. That's what I'm using. So the only difference between voltage and EMF is I'm adding what? The battery to it. What is Ohm's law? I'm sure you can state that, right? Voltage and current are directly proportional at constant what? Temperature. What is power? Rate at which work is Afrikaans now. Werk is what? IS. Done? Werk is Clark. All right, work is done. It's nice to be here. Werk is klaar. Fire. You are saying work is finished. Okay. Dube, which one? The one I wrote right now or the one I wrote before? Oh, werk. No, it's Afrikaans. You tell him it's Afrikaans. All right, guys, these are definitions that we need to know quickly. Not going to wait for you to write all of this, okay? It's going to move quickly because I need to summarize the whole thing. Guys, when it comes to my own electric circuits calculation, I only use one thing to do all my calculations. And what is my calculations? For my calculations, I only use this. South African Police Department is paid. That's all I use for my calculation. That's the only thing you need to remember and do your calculations. What does it mean? Series are, how are they paid? They get paid every day. Series are potential what? Dividers. And what do we know? Parallel are current what? Dividers. Okay. Now, what else? I'm just doing a summary here for you. Is that okay? I bring in this formula. EMF equals to V. Before we go on. I into bracket what? R plus R. What is this capital R? Not just resistance. External resistance. And we know external resistance can be connected into, what do we know? Series and parallel. And it's important to know how to work around series and parallel connections. While this one is called what? Internal resistance. And the thing is, guys, I'm rushing because it's a summary. We can expand this formula as E. You see this formula that I'm going to write now is very important. E equals to what? V external plus IR. This is very, very important. This IR is known as my lost volt. Why? We are saying internal. It is inside the battery. That is my lost what? Volt. Let me quickly explain what this means to you. Guys, I'd love you to listen now just quickly. You can take a picture of this. I want you to listen to this. When I have a circuit with an internal resistance, please, this is very, very important. It's internal. You will see it dotted there. Oh, let's open the switch. If this switch is opened, or I can put a voltmeter here. Let me put a voltmeter here. When this switch is opened, just create a scenario quickly here. We are going to measure EMF when the switch is opened. For example, let's say 24 volts. Just an example. Immediately I close the switch, that value, 24, will drop. Let's say, just for saying sake, it drops to 23 volts. What does it mean? We have lost 1 volt. It means our V lost is what? 1 volt. Please, that's very important. And why do we lose? We lose because of the internal what? Resistance. You'd see when we get into questions now, but I need you to quickly grasp that content there. That when we close the switch, your EMF will always what? Drop. All right, I'm going to go to questions, but just before that, let's play around with what we did yesterday. You know where I'm going? I'm going to graphs. So, we would have a graph that looks like this. I'll look at more of this again as we look at questions. And if anyone finds a question, please bring it. I'll look for more questions as well on graphs. If I have current here, and I have voltage here, what will happen is you're going to have a graph that looks like that. And I want to explain why this graph looks like this to you. Please watch this. Number one, please, I want to explain why you have a negative gradient. I like to explain, I don't know why. Number one, according to Ohm's law, you remember that, right? So check this. As current increases, the lost volts also what? Increases. Why? V equals to I multiplied by small r. If current increases, we are losing more. Okay? Number two. Oh, this is V lost. As V lost increases, V external decreases. So if you check this graph, what do you notice? Finally, therefore, as I increases, I want you to check something. What's happening? V external does what? Decreases. But at a constant rate. That's why you have a negative graph. There was a question that you guys asked me yesterday. How do we know which formula to use? As there are too many formulas, right? Remember? Good. I have voltage, I have current. Immediately I see a negative gradient. Something is taking something away. Negative. Which formula comes to mind? E equals to what? I into bracket R plus R. Remember what we said? It's a straight line graph. Is that okay? It's a straight line graph. What equation are we going to use? Y equals to mx plus c. Are you with me? Okay. Do you remember what we did yesterday? It means that on my y, I should have what? V. On my x, what should I have? Current. In this formula, do you see V? There's no V, right? Oh, but we can expand. So E equals to what? I R plus I times what? Small r. E equals to, that's the V. Makes sense? But I still need I. So I'm going to leave this like this. Which one is on my Y? V. So what do? Bring these guys here. Are we together? So what am I going to have? V equals to what? E minus. Is that making sense to us? But what's on the X? I need to rearrange. Check my rearrangement. Shoaib. Check my rearrangement. Guys, I am not changing the signs because they are not moving sides. But it's still not okay. My I is supposed to be where the X is. So check. V equals to negative. I don't know if you agree with me. Because I times R is the same thing as what? R times I. Oh, do we have it exactly where we are supposed to have? What is my Y? V. What is my X? M. Negative R. Makes sense. Negative gradient. What is my C? Do you see that it's exactly the same thing we did yesterday? C is called the Y what? Intercept. So, what is my C? E. Oh, it means that place is my EMF. And this is called short circuit current. Do you guys know what a short circuit is? That's the question. Do you know what a short circuit is? I should explain it. Explain it, Biggie. All right, this is current flowing through the path of zero resistance. And this is why an ammeter is never connected in parallel. Ammeters are always connected in series. That's completely grade 11. Again, do you see where the graph plays a big role? Y equals to mx plus c. So all the topics we've looked at right now, we've used graphs. All right, let's answer questions. And now I'm going to move from electric circuits to electrostatics, hopefully. But I must get to electrostatics today. Doppler, we shouldn't be challenged with Doppler. It's just, just write ambulance there when the exam. And just write ambulance. Okay. All right, let me quickly run through, because of time, through questions. As we go through questions now, we'll just be revising. Let's check. In the circuit diagram below, an unknown resistor X is connected to a 10 ohm resistor and a 12. Please find those light bulbs quickly. Find your 12. Find them where they are. I'll show you what I do to make my life easy when I do circuits. This combination is connected to a battery with an internal resistance of what? 2 ohms. The resistance of the wires and the ammeter may be ignored. Now, when the switch S, I want you to please, there is an adjective that examiners use here. Let's do a bit of English. It says, when the switch S is closed, check where the switch is. Please be careful. This switch is the main switch. Because if I open that switch, then current doesn't flow. Not all switches are the main switches. The position matters. If I have a switch here, if it's open, do you know current will still flow? Through the other. So be careful where the switch is. If I have a switch here and it's open, current will still flow. But if I have where it is right now, and how will current, this is how before I even go to the question, I trace my current first. Current will always move from where? Positive. Okay, so current is going to come this way. Oh, when it gets here, what's going to happen? Splits. If current splits, what is it? It's a parallel what? Connection. Every time current splits, it means the current, this one is measuring what? The one for 10. What happens here? They combine again, and the total current. I want you to see something here. Do you notice the total current will go through that? Look, understand that flow, and you are beginning to just enjoy circuits. Are we okay? All right. What is this? 2 what? Ohms. Check something here. When switch S is closed, the reading on the ammeter, what? Decreases from 24, or the voltmeter, sorry, decreases from 24 to, they've simply told me 3 important things. They've given me EMF. What's my EMF? 24 volts. They've given me V external. What is it? 21,6. And they've given me V lost. 24 minus 21,6. What's your answer? Come. 8,2. I'm lying. 2,4 volts. Hold on. I wanted to see something. That's the first. Check just that information alone has given me that. The maximum is 24. When I close, it decreases. Please take note. They will tell you sometimes it decreases by. If they say decreases by, in this question, if I want to use by, I will have said decreases by 2,4. English. And it's not your strong point. Okay. All right, but check what they've given me as well. They've given me the voltage. Look, in this place, in this particular, the way I explain this is this. 3 friends always work together. There are 3 friends. First one, voltage. Second one, current. Third one, resistance. These are 3 important friends. They don't leave each other. Oh, and they live in that house where there's a box. You see this box? That's where they all live in. What do I know now? I know my V lost. What's my V lost? 2,4 volts. Do you know that we can current now? I don't know if you see it. What's the formula? V equals to what? I multiplied by small r. Do I know my V lost? 2,4. Do I know I? No. Do I know my resistance? Internal resistance. What is it? 2. Oh, what do? We divide. What's our answer? 1,2 amp. That's the total current. I have not even gone to the question. Just this one information. Check what we've done. Let's go and look at the question. Question 1. Check. Write down the term used to describe 24 volts. It's up there. EMF. Number 2. Calculate the reading on the ammeter. I am done. 5 marks. 5 marks. I must just go and work for ESCOM. This load shedding thing is disturbing me. I'm too good for this thing. Just apply. Jube. Tell your dad I'm coming. But guys, I want you to check the beauty of this thing. Right now you want to get home and just hold a wire. Because of the way you're just enjoying this. Like you just want to, what's wrong? Say, oh, Mama, I just enjoy electricity. I don't know if it makes sense to you though. Just by looking at that statement. All right. But guys, are you okay with what I've done so far? We just want to make life easy and enjoyable. Check the next question. Calculate the reading on, now this is where the job would be. Calculate the reading on what? Resistor X. It's very easy. Follow what you have done already. Do I know current? What's my current? What's my current? 1,2. Check here. That current is coming through here. The total current would pass through here. 1,2 what? Amps. Is that fine with you? What happens at this point? We don't say 0,6 and 0,6, please. Don't. You can only say 0,6 and 0,6 when you have what? Equal resistance. Okay, we have a challenge. Wait. They told us that the V external outside is what? 21,6 volts. How are these things connected? This one here, the two of them are connected in what? Parallel. But that parallel is connected in series to this. Does that make sense? No. Okay. Let's check something. These two are connected in parallel, right? Can we combine them? Let me do a diagram for you. Let's combine them. Oh, that's the only question in this. This is child's play. This is pre-prelims. So, this is what we have. We have our internal, right? We have that. We have that. We have a light bulb here. These two were connected in parallel. Can I just combine them? What do you see now? Make sense? So I've combined my parallel. It's now in what? Series. What do we know? Series are potential dividers. Actually, that's all I do. I use medicine for all kinds of sicknesses. Series are, these guys are connected in series. What happens to potential difference? It's divided. It means the current remains what? The same. Current is the same. Oh, let's go play. What is the current here? 1,2. What is the current here? 1,2. Do we have this? 12 what? Ohms. Make sense? The total voltage here is what? 21,6 volts. Are we okay there? Something is missing here. 3 friends play together, but 1 friend is missing. Friend. Someone is missing. Who's missing here? We have R as 12 ohms. We have I as 1,2. Who's missing? Voltage. What's the formula? V equals to IR. What do we have? 12 times 1,2. 14,4 volts. Makes sense? 12 is 44. And there's 1 decimal. So it's 14,4. Wait. These guys are connected in what? Keep repeating the acronym in your head. Oh, it means they take the whole potential difference and then what? Divide it. Oh, so if this one has now taken 14,4 volts, what is left here? Oh, it's easy now. The voltage in the parallel connection will be what? 21,6 minus 14,4. What is your answer? 7,2 volts. Please, are you okay so far? Are we okay? 7,2 volts. Biggie, are we okay? Guys, do you remember what this is? It's our parallel what? Connection. I just like to do, if you understand this, you can answer almost any question. Since they are connected in parallel, what do we know? Parallel are what? Current what? Dividers. What happens to potential difference? Potential difference what? Remains what? The same. Are we okay? Let's check. What do we know? On the other resistor, let's check. We have 10 ohms there. Oh, sweet. Now that we have 10 ohms, this is X. What is this? 10 ohms. Make sense? But we know that the total current is what? It's not 1,2 in each of them because current is what? Divided. Make sense? But the potential difference paid. Parallel are current what? Dividers. It means the potential difference remains what? The same. What's the potential difference here? 7,2 volts. What's the potential difference here? I wanted to, I could have done this in a shorter way, but I want to answer the million questions that we have in circuit by using that method for you. It answers just everything. What are we looking for? We're looking for what? The value of what? X. Oh, it's easy. To get the value of X, can I get the current there? Yes, I can. How do I get the current? I'll show you how to use ratios. Ratios are the easiest. Guys, someone is missing here. Always look for the missing fellow. What is missing? 7,2. Resistance is missing, right? Huh? Test me here. So here, what is missing? Current. V equals to what? I R. Look, this is the easiest way to flow through. Just flow step by step. There's no need to do everything at once. You'll get it confused. Okay, what is my V? BB, now you are busy. I, what is my resistance? 10. So what is current? 0,72 amps. Oh, now that we know the current here as what? 0, but the total current is what? 1,2. We're dividing the current. One part is 0,72. So what is the current here? 1,2 minus 0,72. What's your answer? Someone is missing again. I want you to see that I am using the same principle to get to my answer, which is the easiest way. Someone is missing. R. Oh, so I know that V equals to what? IR. What's my V? 7,2. What's the current? 0,48. R is missing. What's your answer? 3,46. Are you sure? And what's your unit? Guys, I just wanted to use the same principle to walk through. For me, it's the... What's your answer? Okay. R equals to what? 15 what? 15 comma? Okay. Guys, I don't know if what I just did made sense to you. Just walking through the circuit and using one single acronym. Series are potential dividers. Parallel are current what? Dividers. Make sense? So check how your resistors are connected and just walk through the system. You're fine. Already we have 9 marks from this calculation. If we check, we've got the first 5 marks. Now we have what? The next 4 marks. Are we together? It might look a bit clumsy now. Let's look at the next few questions, okay? And then you'll see that I'm going to use the exact same principles to walk through. And then you just enjoy the flow, get back home, practice that. Once you get into the groove, practice that system. It keeps working. Always look for who is missing. All right. How would the brightness of the bulb change if... Okay, there's something I'm going to quickly teach you here. There's something I want to teach you. But let's see first. How would the brightness of the light bulb change if resistor X burns out? Explain your answer with relevant power formula. Okay, let's check. What do you think will happen if X burns out? Let's discuss. When X burns out, it means it's no longer working. What do you think will happen? Okay, I want you to answer me in terms of physics now. What happens to the first thing you do is to talk about the total resistance when you see a question like this. Will it increase or will it decrease? Please be careful. Don't jump. If you are not sure, calculate. Oh, let me test you guys. Please calculate the total resistance in this circuit for me. We know this one as 15, right? Let me just check something. Let me check a grade 10 concept. Calculate the total resistance in this circuit. Everybody, those at home, calculate. I need the total resistance in this circuit. Guys, I want the total external resistance in this circuit. I want total external. Tabang 8. Idris 18. Idris 18. I want the total. I'm very clear. I want the total external resistance. Total external. How can you say, Biggie, how can you say 6 when one resistor there is 12? Total external. There are 2 parallel here. We can simply use product over sum. I don't know if you know that formula. If you have 2 resistors that are connected in parallel, you can just say product over sum. What is the product? 15 multiplied by 10 over what? 15 plus what? 10. I want to show you how, so that you don't think too much in an exam. Work with things that you're sure of. All right. Mind you, there's another one connected in what? Series to them. So what do we say? Plus what? 12. 18. Okay, I've got two questions. Can we use? You can, but not like this. Not like this. You've got to say product of the two plus the product of the two plus the product of another two. So it's complex. Yeah, just use 1 over R. Yes, Biggie, your question? All devices are resistors. Any device. All devices have resistors in them. That's why they work. If it doesn't have resistors, it won't work. All right, guys, are we okay there? Now, check the question. Please listen now. Examiner now said X burns out. It means X no longer works. Will the value of the total resistance increase or decrease? X now burns out. It means that X is no longer there. We only have how many resistors? 2, which are what? 12 and 10. And what's your answer? 22. If you are not sure of how to deal with that, that's what you do. All right. So it means the total resistance will what? Increase. It's internal. We said external. If you go back to my formula, I did clarify the difference between the two R's. Right? External, internal. So now we are saying that the total external resistance will what? Increase when X does what? Burns out. Okay. So let's quickly look at that. X now burns out. Let's go back. Just want to create room for us to be able to deal with it. And also calculate cost. Cost is a grade 11 concept, and the examiner is just bringing it in here. Sweet examiner. Okay. When X burns out, guys, what do you think will happen? What did we say? Start by dealing with what? Resistance. The total resistance will what? Increase. Guys, what is the relationship between resistance and current? They are inversely what? Proportional. So, if total R increases, what happens to total I? Total I will what? Decrease. Making sense to you? Please watch this. This is what I want to teach you. If total I increases, what do you think will happen to my lost volt? Lost volt will what? Decrease. Right? V equals to Ohm's law. V and I are. Use an acronym for you here. And finally, if my VD, this is the graph. We spoke about this just a while ago. What happens to my V external? V external will what? Increase. Remember, E equals to what? V external plus what? V internal. If this value decreases, I want you to check the flow. I'll summarize this now in one simple statement for you to remember. I call it revive. Revive. And please don't ask me if that, but revive is spelled as R-E. R-E. Please, that's English. Even English people don't know English. Revive, they say R-E-V. Check English. English. Look at English. What is that? What is this? River. R-E and R-I. Re and re. So please leave my revive alone like that. It's re. Because how can R-E be re and R-I also be re? So please leave my English. Revive. All right. Now, please. Now, revive. What do I mean by revive? The first R is what? Resistance. If resistance increases, we know the relationship between current and what? Resistance. They are inversely what? Proportional. What will happen to current? Current is I, right? Current will what? Decrease. What is the relationship? I and R are inversely. I'm done with the first two. You see that? What is next? VI. Voltage internal. According to Ohm's law, if my current decreases, what will happen to V internal? It will also what? Decrease. What's the connection here? V and I are directly proportional. What is the next? V what? External. If VI decreases, VI will what? Increase for the same EMF. So revive is key. Revive. Resistance. Current. V internal. V external. If resistance, the relationship between resistance and current, they are inversely what? Proportional. Current and voltage, they are directly what? Proportional. Come here. Check this. E equals to V. Let's have a battery. Let the battery be 24 volts. Let my V external, we're just using scenarios, numbers, so you see what's going on. Plus 4. Okay? What did we say here? V internal does what? Decrease. Let's decrease 4. But this is still the same battery, so that is 24. What happens to V external? For you to balance it, what's the value? 22. Do you see this one? What happened? Decrease. What happened to VE? Look, a quick way to look at this is the word internal resistance means a resistor inside the battery. It's likened to a woman who's pregnant. Where's the baby? Inside. Why do pregnant women eat more? Tess? To feed the baby. Lovely. Now, if you have, do you think that someone who has twins and someone who has one baby would eat at the same rate? I don't think so. Someone who has twins will eat more. Why? There are 2 of them. So it means when she eats any food, she loses more. I don't know if it makes sense. So V lost increases. V external is what she gets as a person. So if one baby were to take 2 joules of energy and she drinks a bottle of Coke of 20 joules of energy, one baby takes what? 2. It means she lost how many joules? 2 joules. She took what? 18. If she has twins, she lost what? 4. Do you see, the more she loses, the less she gains now. She loses 4 joules. She's going to gain what? 16. Do you see that as V internal increases, what happens to V external? Decreases. Make sense? Tess, wait, you're not pregnant yet. When you get pregnant, you'll understand. Okay. All right. So I hope this makes sense. And this is your key word, revive. Why am I using this? That's the way I am going to answer my question. What have we said? So the first step is to look at what? Resistance. What happens? Resistance what? Increases. Total current will what? Decrease, because they are inversely proportional. Lost volt will what? Decrease. I am using what? Ohm's law. If my V lost decreases, what happens to V external? It will increase. Watch this. I am going back to my question. I want you to see the marks. You see the mark allocation there? 4. So what have we done? We have removed X. What happened? Total resistance increased. Current decreased. Lost volt decreased. V external. It means there's more voltage here. What is similar power? you remember the examiner says what? Use a relevant what? Power formula to explain. If you check your formula for power, what do you notice? P equals to what? V squared over what? R. Formula there. Check your, is it there? Good. Which means for the same resistance, for the same what? R, an increase in voltage will increase what? Power. Does that make sense to you? Check the formula. P equals to V squared over R. If V increases to P, it will also what? Increase. We are done with the 4 marks. But you cannot be here until you start from where? Revive. R, resistance. I, current. VI, V internal. VE, V external. So in this case, we said our total resistance what? Increased. Current what? Decreased. VI what? Decreased. VE what? Increased. So if VE increased, an increase in voltage will increase what? Power. P equals to V squared. Simple. This is now content. This is now, we've gone beyond. It's all calculation, but we are using words to explain the calculation now. So that is how I answer my electricity questions. Revive. I promise you, if you get this, you are going to copy and paste this system in another question. Grade 11, calculating cost. The cost of electricity is R1.30 per kilowatt hour. Please, this is the only time you calculate time in hours across physics. Every other place in physics, meter per second, or second. But here, we calculate in what? Hours. The bulb is used for 40 minutes per day. Oh, this examiner. Assuming that there is, this looks like the Met question of the hotel now. Assuming that there are 365 days. I mean, what's the problem? Just tell us the number of days and... Okay, please check. The bulb is used for what? 40 minutes per day. But there are what? 365 days. What does that tell you? How many minutes for the year? 40 times what? 365. Okay, so let's calculate time first. Please remember this value for me. R1.30 per. Okay, the cost of electricity, assuming that there are three, we calculate the cost of running the bulb. Remember? The. So we are still referring to that same question. The bulb. All right. Let's go check something. Let me quickly show you how to get this, and then we are done with this question. Let's see. All right. Calculate cost. What is time? What did we say time is? We said 40 minutes times what? 365. What's your answer? 14? But this is what? Minutes. Time must be calculated in hours. How do you convert to hours? Divide by 60. Beautiful. So, 14,600 divided by 60 would give us what? 243,33 what? Hours. So this is what the light bulb was, how long it was used. Are we okay? That's time. That's the first concept. Number 2 is to calculate power. Power of the light bulb. There's something we know about the light bulb. R is 12 ohms. Do you remember that? What is current? 1,2 ohms. Do you remember? Was it 1,2? No, amps. How are we going to get power? Using those two formulas. P equals to what? I squared R. What is my I? 1,2 squared times 12. What's your answer? 17, 2, 8. Not 28. What? You said 28. And it's not 28. I think I've corrected you on that. 28. What about this? 17,281. What about that? 17,2817. What about this? 17,28,177. What about this? 17,281,700. Okay. All right. So check this. Now, wait. We have power. I want you to notice something. This is where the key is. What is the unit? The unit we're given was how much? 1 rand 30, I think. I want you to watch something. It says per what? I know you didn't take that, and that's where the answer is. I'll take you back there. I know you didn't take note of it. Please take note. Should you forget, this is what you check. Per what? Kilowatt hour. The power must be converted to what? Kilowatts. And time is converted to what? Hours. Please take note of that. Kilowatt hour. How do you convert watt to kilowatt? Wait, before, don't jump. How do you convert from kilowatt to watt? Let's do this to help you remember. 1 kW. Every time you see K, it's 1,000. You got what? 1,000 what? Watt. I don't want you to cram anything. These are common things that we know. K is 1,000. Even money. People talk about, I need 4K. They're talking about 4,000. All right. Go. Sure, now you're smiling when I say 4K. You like money. Okay. But is it making sense? But wait, how many watts do we have? 17, 2. I want you to understand, and I don't want you to make mistakes. What do we have? 17, what? 28 watt. We are looking for X. What do we do? Cross multiply. 1,000. Some of us know that we just need to divide. But just to make sure that everybody is on the same page. Okay? So what do we have? What is X? 17,28 over what? 1,000. Now that is my power in kilowatt. Now what is my cost? It is power times time times unit cost. What is our power? 0,1728. What is our time? Oh, there's a 0 before the 1, right? 0,01728. What is our time? 243,33. And what is the cost? 1 rand what? 30. What is your answer? Okay, come down. 5? 5.47. 5 rand 47 cents. Really? Okay. 5 what? 5.47. Okay. Why do we have to use? Okay. All right, guys. This is how we calculate what? Cost. It's not a common question in grade 12, but it's not an unaskable question. It's a grade 11 concept in most cases. This is how we calculate what cost. Please remember, the key thing is your power must be in what? Kilowatt. Your time must be in hours. And then you multiply by the total what? Cost. Guys, look, if you understand what I've done here today, on circuits, we can just answer any other question. All right. Was this in the paper I sent to you? Leslie, whoever told you that, like Leslie, you always listen to lies. Whoever told you that lied to you. So Leslie, please stop listening to lies. You were the one that said they said paper 1 difficult, paper 2 is lighter. Those are all lies. Okay? Stop being fed with lies. All right, guys. Was this question there? The paper I sent you. Okay. All right. All right, let's see if... just need to talk to my grade 11s and see if they can allow you. But I would let you know. But so far, so good, please. We answer one more question on circuits. We do 2 on electrostatics, 2 on Doppler. Then the rest of the day we deal with what? Our mechanics, momentum, and all of those. Okay? I hope that we are okay with what we've done. Please, guys, I don't want any one of us to make mistakes. Be careful when we do the calculations, but most importantly, remember your concepts. Concepts are important. Once you remember the concept, then you're good. Yes, guys, I'm done because of time. Load shedding. Biggie, your question? No, they are not indirectly proportional. I knew you were going to go there. They are not indirectly proportional. Just that as one increases, but they don't have a constant rate of change. Okay? They don't have what? A constant rate of change. So they are not inversely proportional. But as one increases, the other one what? Will decrease. It depends on current. Okay? Depends on current. Leslie, quickly ask your question. Quickly ask. You have 1 minute or so to ask your question. Quickly, if you need to ask. Yeah, we did that already. A negative gradient graph. That was done. And I explained why the graph is also negative. Where is it? There we go. And we explained why the graph is negative. We said as current increases, the lost volt increases. And as the lost volt increases, V external decreases. So as current increases, our V external decreases. That's why we have a negative gradient. And all you need to do is to use your Y equals to mx plus c. So use your Y equals to mx plus c. Your gradient becomes internal resistance. So all we did was to rearrange. You see, we rearranged in terms of Y equals to mx plus c. So you would notice my Y is V. And my X is current. So my M is negative R. We just compare. It doesn't apply in question. Okay, I don't understand what you mean, Leslie, when you say it doesn't apply in questions. If you find a graph question, you've got to apply that. If you have a graph question, you have to apply that. So I am a bit lost.